Hello and welcome. Today's webinar is on on-site wastewater engineering and design. My name is Addison and I am the Executive Director for the World Geospatial Industry Council. WGIC is the only global trade association for geospatial and Earth observation companies. Thank you for participating today. And before we get started, we have a quick poll for everyone. While we're completing that poll, I'd like to introduce our topic today and tell you a little bit about what we'll be covering. GIS is used, as you know, by local governments for managing on-site wastewater systems in a myriad of ways, not just systems, but also septic systems that we'll be talking about today. Our speakers are certainly knowledgeable on these topics, and we'll be covering a wide range of areas, including field data collection, mapping and inventory, assessing risk, the policy, regulation, and compliance around on-site wastewater, and then finally, planning and development. We'll move then into public health monitoring, sort of after the systems are in place, and round out our discussion with education and outreach. So you didn't come here to listen to me today. So before we get started, let's take a quick look at our poll results. Many of you I see from the local government area, followed by state and federal government. Very nice. And with that, I would like to introduce our first speaker, Jay Hoffman from Esri, who will be presenting on sewer manhole inspection solutions. Take it away, Jay.
Great. Thank you, Aaron. I appreciate it. So again, my name is Jay Hoffman with Esri. I'd like to welcome everybody to the webinar here. I'm with our water global practice. We also assist local government as well. So what we'll be going over today is sewer manhole inspections. So I want to kind of just talk a little bit about that and kind of think about, what do you do today for your manhole inspections? Are you still doing paper workflow, or are you doing digital through GIS software or other types of means of that? So a little bit about Esri. Esri's been around for 54 years. We have about 15,000 water utilities and more of local governments that use GIS software for all different types of tools that Esri has to do what you need to do within your organization. It's owned by Jack and Laura Dangermond out of Redlands, California, and Esri is a debt-free company and going strong. ArcGIS Solutions. Want to talk about a little bit about this. This sewer manhole inspection is one of our solutions. They range from all different types of sectors within Esri. So down here in utilities, this is the manhole inspection. Some of them were that everybody just got done finishing with is the lead and copper. I'm sure everybody's glad that that's done. But now the other half of that's got to come to fruition for the next 10 years or so. To state and local government that we may have on today, one of them from customer service that I like to talk about is a citizen reporter. These solutions are no-cost solutions with Esri licenses, and they're already built. So we always like to say you want to be agile, and then agile first, and then customize second. So I always say get to know these solutions really well, and let them be your best friend. And I have several folks that's all they deploy, and it gets them done. So you can check out local government on the solution pages as well as utilities with that. So some of the challenges that are run up against, according to EPA, is that most systems have many manholes, obviously, so much along a street line. Without managing them, You know, that can be a big problem. And inefficiencies from creating leaks, cracks in the sewer lines, you know, building up the grease blocks that if someone's not being good stewards of what goes down in the sewer, you can run into a lot of other things that will drive up your operational costs and not make it good for everybody else that's maybe along that line of that sewer manhole. So what we'll kind of talk about is how the streamline manhole inspections and understand manhole asset conditions through this manhole inspection. And then I'll be showing a little demo as well. With the sewer manhole inspections, all of these solutions come with focus maps and apps. So this is what you would get. So when you download to either ArcGIS Online, or if you're using Enterprise, you can do it for both. This will put links in there, and then you'll start. And what I'm going to do is just kind of show a little bit of some of this inspection that you can see, kind of some of the workflows that we'll be able to do. So let's get into the solution. Let me stop sharing my screen here. And get into the sewer manhole inspection. When you first open that up, this is what you're going to see. So what you do is you're going to plan the inspection, then we're going to assign the inspection, and then this also will get assigned to your folks in the field, your field techs. And then we'll look at some dashboards real quick on there. So we go over to the plan. These are all, let me show you some some legends here. So as far as workers, when they get assigned, you'll see the, not working, on a break, or working. So you would know, be able to see how, who you could assign this inspection to, the assignments, unassigned, assigned, in progress, here. And then the manhole last inspections is, the size within the last year, this color between 1 and 3 years. These are all symbology that's in this solution. And then as far as your condition on the condition, so the size, as it gets larger, it's not very good condition and stuff. So all of these right here that we see on the screen, these are ones that have never been inspected. So to look at some of these, so I'm going to come over here and I'm going to start assignment here, and then I'm going to come down, and you have these options of either copy by rectangle, by polygon, or by lasso, and I'm going to choose by rectangle. And then kind of what I'm going to do is I'm going to just kind of select these here. And so I've selected these that I want to inspect. So I'm going to come over here to apply field mapping. And so this is our database here. And so we're just going to apply that. And then it puts those boxes around there of those specific ones that are going to be inspected. And then we want to create our features on that. Now what we want to do next, so what that did is once I created the feature, it turned these 5 of them gray. So they're ready to be assigned. So as you can tell, so I've got this one here, this inspection. So if I were to turn that off, turn this one back on, you'll see that one there. If I turn that one on, it turns on another one. Here's another one here that is turned on as well on that. So what we do is we can get into, then I can look to see an assignment. I can see all my field workers in the area, so I can see that this content admin has a few, Matt Kennedy here has several, and then you can go down and look. So let's just assign that the people down here, they're not working, so we can't, they may be on vacation or away for lunch or whatever the case may be. So we want to assign those here. So we capture, so we've got all of these. If I click on this inspection, that one, and then that one there. There's probably some other areas here. These were the 5 that were there. So if we just focus on those 2, then what, for the sake of time, basically, we would then assign the type that it was. So we can say, you know, it's a grease block that needs to be broken up because it's preventing the flow of the water through the sewer. So we want to call this critical. We could do a due date by tomorrow. We can say, hey, we want this time. If you have an asset ID, you can move that asset ID, put that in there. Then we put need to break up grease block, and this message will get to that person. And then if we do an address, so we want to find that address. So that looks like that's on Benton Avenue. I'm just going to kind of show that up here. There. It's kind of going back and doing another another assignment. So what that'll do is then, because I don't have the part, when we hit assignment, when it goes to assignment, then it sends a notification to the device of who we selected. And then what they do is they'll pick up that, they'll see all these notes here. And then they'll drive to where that is. They'll do that inspection. When they're done, then it'll be completed, and it'll show complete back in the office. And then that person at the office can see where they're going to the next, as well as where that particular field tech person will be driving to. Once all that's done, then, you know, if the general manager or anybody supervisor wants to see what's going on, they can log into here, and they can look at assignments, see who got assigned from the next person. That takes a little bit of time. So what it's doing is this is one of the other things that comes with the with dashboards. Dashboards are very telling on what's going on in the system. And this big map will come up here shortly. So we can see that at the very top here, you got Ben's. This is Ben Siegel here. He's got these 2, and then we had gone through and canceled because we were cleaning up our assignments and stuff, making it a little more easier for the field tech guys so that they could see there as well. Not sure why that map is not coming through on that. Then as another dashboard, we can look at the inspections. This was the assignment dashboard. So that changed. Look at that. There we go. So this will bring up another dashboard that's part of those focus maps and apps that you get with the solution. Should that come up? Well, there we go. I think that's finally coming up there. So these are the manhole inspections. So, down here is the manhole inspection, the oldest first. This is the asset ID of that specific asset. A lot of people will have the asset ID and keep track of it in that manner. Guess that's not going to come up on there. So this will kind of give you kind of a workflow on how that. So you do everything back in the office to assign that. It sends it to your field techs in the field. They do the work. And then once it's all completed, then that person can then pull up these inspection dashboards or the monitor dashboards as the stuff kind of starts to come in a little bit for the sake of time here. So let me stop sharing this and let me get back into the presentation real quick. So again, this was all the focus maps and apps here. So kind of a recap of our sewer manhole inspection. It streamlines manhole inspections. It keeps everything, flowing, if you will, no pun intended. To manage the activities, make sure the inspections are going well and everybody's in sync with that as well. So that's probably it. So I know we'll have time for questions later on. So remember ArcGIS Solutions in your resources down at the bottom. You can click on that, or it's just a matter of going to solutions.arcgis.com to find out more about these.
Welcome to Woering from APGLOS. Take it away, Ray.
Oh, yes. Thanks, Jay, for introducing me. Everybody, welcome to this webinar. Let me share my screen. Share. And let me start my presentation. So again, everybody, welcome to the webinar, GIS for on-site wastewater engineering and design. My name is Ray Woering. It says Raymond actually, but well, Ray is easier. I'm the CEO and co-owner of APGLOS BV, and APGLOS stands for Advanced Positioning Global Software. We have intuitive field software for GPS surveys in all water management applications. And we wanted to make advanced iOS and Android surveying apps, and we made it like optable by any field worker. So let's go to the next slide. Before I start doing everything telling about my software, I just wanted to add something about water management. As you can see in the screen, I put some nice pictures there from the country we're originally from. We're actually from the Netherlands. And once the United Nations had a development goal, the Sustainable Development Goal, it says ensuring access to clean water and sanitation for all. That means that water management involves the quality of the water and the quantity of the water. And to be sure, a little bit give you an insight on what the Netherlands actually is. Well, the Netherlands is very well known for their water management, and it has to do something with that almost 56% will be under sea level. So we need to be protected by all the water infrastructure we have. So, for example, if you go to Amsterdam, it can reach up to or less than 20 meters below sea level. So you can imagine if it happens something with the dikes, there will be the Netherlands at least 56% anymore. And we're actually a delta. That means, okay, I made it a sinkhole or a drain for several European rivers because the bigger rivers from Europe will run through the Netherlands itself. And also something very other nice thing about the Netherlands is that we have a very, very small country. It's only 300 by 300 kilometers. It's the metric system. But you have to remember that we already exceeded 18 million people. And that means that in 2050, we'll exceed even what they accounted for, about 22 million people. So for us, it's very much important that we do the water management. I also showed a very nice picture below. I think that's a view from Amsterdam. You see some windmills in the background, lots of water and housing. So that's all about the Netherlands. Let me go to the next slide. Water management. Well, water management involves a lot of things. In the top, you can see a sewer treatment plant, and then you see this nice guy using a GPS system, which is actually me. And besides civil engineering, you know, it expands the dikes, the canals, and we also have a very special and unique infrastructure to do all our water management. So with all that said, we also need to do wastewater and recycling, which comes all the way to the topic which this webinar is all about. With that said, it also has asset management inside and maintenance. And with all that, we need to collect geo information. So let me go to the next slide. So what I actually did, I put our software exactly in the middle. Our software is called the APGLOS Survey Wizard. I can explain a little bit why we call it the Survey Wizard. We find it a wizard and a survey wizard. That's not only because we do have an office at the Castle Addison, which I'll show you in the end, but we find it a wizard itself. Because what you can see here in the top, it starts everything in civil design, build, and civil engineering with CATs. First one, you know, you need the civil engineering, wastewater, we need to do the maintenance, we need to do the design before we start going to the maintenance and asset management. So that can all be done within the center of my sheet, the APGLOS Survey Wizard. And then, of course, you need the GIS. It's the asset management, which is very important because without asset management, we need to know the components as well as the updates. So still APGLOS is in the center because the only thing you need is a controller, which can be your phone or a tablet, which you can use. And within this APGLOS Survey Wizard, which we built actually, you can put your GNS corrections like a base rover setup, and you can enter your N-trip data if it's local or globally. And I put a nice bad elf mini flex on the right, which is a GPS receiver, which you also need. So let me go to the next slides. The basic where we actually started developing our software because we saw some challenges and we saw a global trend, which I first thought it was a little bit within Europe, but meanwhile, while traveling and doing this company for several years, we saw that there's a decreasing number of well-educated and skilled surveyors. So we thought we need an answer to all that. It was thinking outside the box. Just keep it simple. Make GPS surveying for everybody. All this was based on that we once had a good running engineering and construction company, and we were very much in need of land surveys that helped us doing the on-site surveying. Well, it was quite difficult to find any land surveys, or at least skilled land surveyors. So we tried to purchase like a GPS system to collect our data. So what happened actually, we couldn't find anyone, or my people were not educated enough to equip this equipment or to run this equipment. So what we actually wanted, we put all the geodetical aspects, we integrated everything, and was all managed in the background. So once in the end, you can download maybe our software and can see for yourself. To make it a little bit easier within this software, we wanted to do also an iOS and an Android application because we found it would be more appealing for young professionals. You know, I'm getting a little bit older, but there are plenty of these young professionals that really likes the apps. I don't know if anybody has children. I do have, and I know for one thing, they really love their apps. They really love their phones and they really love their iPads. So So that's why it's also basically because they have to run it after we are gone. So also what we wanted to do is do a predefined coordinate systems. We entered over 5,200 plus coordinate systems, and that included the United States of America and Canada. You see within the USA as well as in Canada there are multiple ones, and for the Netherlands it's just only one. So we made it a little bit easier to enter that coordinate system. And besides that, we also wanted to integrate and help our end users. So under the eye for information within our app, what we actually did, we did support videos. With those support videos, you can click on tutorials and whatever you want to do, like stakeout, gathering, collecting, making layers or whatsoever, there will be a small YouTube video that will help you through all the functions. And then also, we also wanted an offline mode for remote areas because definitely, well, in Europe, it's quite good cover, but I know places. I went to Las Vegas, the last conference in February or January, and I went outside, and the first thing I encountered, I had no mobile device or no mobile range. So then it can be easy to have access at least to your land survey software and collect your data. Also within the software, we have the options of predefined workflows and that we made to minimize errors because I can find it should be a sewer pipe, but anybody else can say, no, that's just a pipe. That's why we predefined everything. So that data capturing, it minimizes errors in the rework you have to do if you don't collect it in the right way. The challenges. Let's go to the next screen. So here you can see a small screenshot of the APGLOS Survey Wizard app. What you can see in the first screen is the land survey. Once you start it up, you just enter the land survey part. On the background, you will find the Google Maps, which is actually like a screen that will follow you. So it will not be, I just see the coordinates. It's an interface. Well, within the app, we support all CAD and GIS file formats. For example, the DXF, the direct exchangeable format. The most heard question I hear from the ground, can you also enter like a DWG? No, that's not possible because the DXF will support all CAD programs that are available on the market. We do also shapefiles, CSV, TXT, XML and XML, KML, etc., etc. And then because we already are running some pilot projects, again, with one of our partners, Bad Elf, and then from a lot of these construction workers that do the on-site planning of the sewerage, I said, is there also a possibility that I can generate a PDF straight from the app itself? So what we actually did, we did a built-in PDF, some sort of a converter. You just save as, just fill in your name, the date, time, and some extras, and you get a full drawing in PDF that you can immediately send by using the save as option. So also within our application, we made all survey functions included. So besides the land survey, you can stake out. We have like a small calculation options from height, average height, areas, volumes, etc., and a drawing options. And also what we want to include is that we really do want to be independent. We do want to be independent from any GPS. So any GPS or GNS hardware can be added and used within our software. As what I told before, the app is an iOS or Android-based app. So you can run it on your phone or a consumer tablet. I made a consumer tablet, but any tablet will do, as long as it's an Android or iOS, and even the special rugged devices. And within the app, once you make a connection and you can fill in your own N-trip data, and it will support all GNS correction service providers, our course network. So let's go to the next screen. Well, it's also the end. I'll leave some contact details there. We have our website. You can go to www.apglos.com. Our YouTube channel, and please subscribe. We have approximately 300 of our videos there. Even we show you how you can build your GNS receiver from Lego if there are interesting people how to see how to do that. And as well, the link to the downloads are mentioned there, and a link to our partner, Bad Elf. And I made a small picture where we actually had. I told you in the beginning, we do run our office from a real castle, and that's called the Castle Addison, and it's based in the Netherlands. So if anybody wants to come and visit us, please be welcome. You can connect to me. So let me stop sharing the details. And well, actually, I'm finished with my presentation. I hope everybody enjoyed it, and I just want to introduce our next speaker, Mr. James F. Prochaska. I hope I speak it well, James. Sorry if I mentioned your name. So thank you very much.
Looks good, Jim, but you want to go into slideshow mode. That would be presenter mode. So we're seeing your notes there. You want to go lower right corner. There you go. Got it.
Okay. All right. All righty. All right. I'm Jim Prochaska. I'm a professional engineer, have a couple of companies actually that have been involved with the work with what we call on-site wastewater. And just for definitions, a little different than what we've heard in the previous presentations, that we're concerned with areas and places that don't have wastewater as a utility. Okay, we bring the utility into it. This can be into a small system for a home all the way to a subdivision. All right, so who we are is we're basically, we do design, we do project consultation, site and soil evaluations for dispersal areas, which means we look at everything that's there at the site, on-site design and permitting and we were established in 1994. Okay. But we're not a survey company. We do use surveys. We do use information. Our world moving into GIS now, information that's available. Oftentimes, the engineers ahead of us have gotten to that, and they've already taken and provided that information. So typical projects include the single-family homes, subdivisions, as I talk about, with no sewer hookups. Travel centers, these are going to be the travel centers typically we find along the major highways. And we look at what's going on there, whether they have food, showers, diesel, being they have trucks. The other things we look at are the use of schools, mainly rural schools, industrial parks that are going to be these in the U.S. today. We have a lot of these large industrial parks being built up with buildings in the several 100,000 square foot range. Each of these typically are outside of town and are going to be needing some type of sewer system, something to handle their wastewater. Okay, where am I? This is the problems we saw when we go out there. We don't know where we're at. We walk out into a project. We ask ourselves, okay, we've got maps. We have certain things but if you're in an area that has not been developed, then we're not sure where we're at. So our goal has been to find a easy way for non-surveyors like ourselves to be able to go out onto the site and know exactly where we're at. Our introduction to GPS equipment over the last few years has provided that tool for us. The folks at Bad Elf have been very, very helpful to us to train us on how to use their equipment to do that type of thing, so that we're capable of moving in and out of a site. So the kind of things we're looking for once we get out there, where are the features that we need to stay away from? Those are going to be things like wells and other boundary conditions like borders and stuff. Property lines. And then we need to know where the features are that we must include. And some of those same things have to be put onto our plans and been brought into our designs. So so all those things are something that we compare to our paper plans and then to the real world. Okay. Our typical workflow plans or site locations, we get all the information we need about that from either from published data that's there from various organizations like the counties, state, other GIS providers. Then we determine the points of interest and get on our maps before we go out to the site. We find points of interest in the field and then take the readings once we get there. Take additional readings based on our findings. We'll get out there and see something that's okay, that's going to have to get included in our plans. We bring that into it. Bring in points. Then once we get everything together, we start working onto a CAD plan. We work with into something that we're going to be able to build onto. We design around the points of interest. Take new points for as-built drawings as we move through the progress through the project, and then at the end of the day, or before we even start, we determine what what information is available via GIS and what may be out there. Okay, identifying points of interest. The tools that we typically go to are available GIS. Typically, it's the county CAD maps that are available. And oftentimes, these are going to include topo and things of that nature. Commercial surveys. On any of the larger projects that we're involved in, normally a commercial survey has been done. Basically, a licensed surveyor has gone in there, mapped out the property once again, and then presented it back to the civil engineer, who's the next person to get it. And then they provide us with the demarcations as to where our areas for the on-site wastewater treatment and dispersal is going to be at. And then last but not least, soils maps provided by USGS and also by NRCS, people like that, provide us all types of information there as to what's going on, what's been mapped over over time. As these things have been going on, and then what can we expect and what can we do with them. Okay, so in our pre-design site visit, we're going to set up our maps. We're going to say, okay, here are the things we need to look for. We look at especially at the sites and areas that we've been assigned for our wastewater prior to the site visits. Once we get out there, we start taking the readings of the points of interest that we've identified, and also those that we are finding as we get out there. In certain states, the state of Texas, for instance, we're very concerned with drainage features, or we're concerned with in central Texas, for instance, what happens with water in the karst topographies that we have. So anything that looks like it's going to be drawing water into it, we want to stay clear of with our wastewater systems. Okay, so what I want to do now is go through a few examples of some of the systems that we've worked with and types of things. Again, we're a design firm, not working with the whole thing. We're not building the subdivision itself, but we're on the wastewater side of it. In some cases, we get involved with the design of the wastewater treatment package itself. But for the most part, we're looking at what do you do with the water once it gets done. We're trying to put it back into the environment. Okay, so I said before that some of our typical things start with residential. We may be in just a system in the backyard someplace. That's a very common thing in many of the states. Okay, and here's just basically a typical picture I like to use. We use subsurface drip irrigation and spray often, but primarily subsurface drip irrigation. And the little bumps along here, you can tell where the drippers are in that yard. Here's another single family is building the on-site system into the landscape. This is in Malibu, California, nice place. And but the on-site wastewater system, where basically where the water goes after it's been treated, is now part of the landscape. Schools and sports complexes. That's another big thing we get involved with, especially those that are rural. And you can imagine that's going to be as we build out and we build out more and more, the schools are moving out with us. They're no longer necessarily central part of the city. Travel centers, I mentioned earlier, many of these are being built along the interstate highways, especially. We get involved with many of the different ones that are going in and providing equipment all the way from the treatment side of it in our designs, all the way to what's going to happen with the water in the dispersal side of it. Let's take a look at some of the a little bit larger as we move on up. This is a project we call Ledgestone. I just left the title in there. It's a nice name for it. And phases 1 and 2 of this thing. Basically, we had you have a subdivision that was put in not only individual homes but also apartment buildings. We have a retirement center in here, and now we've got also a commercial sector being put into it. All of this being used. All this area and the site itself is contributes to a on-site wastewater system. Basically, the treatment package is there, and then all the water that's treated there is also dispersed on site, so that none of it's being dispersed into streams or anything of that nature. Here's a large one that we did in the state of Tennessee called Fairfield Glade. It was a 250,000 gallons per day on about 30 acres. Here's a lagoon process that was being used to treat the wastewater. This is a 500,000 gallon per day one that was on about 300 acres up near Amarillo, Texas, and was on a property that belonged to the government. Million gallons per day. These systems get on up in size, pretty good size. This is one in Thompson Station. If you travel to Middle Tennessee, you'll run across this one in your travels out there. And it's one of the ones that we've been highly involved with over the many years, and it spans many miles. So we've got in our systems where our treatment and where our dispersal ends up, we use radio and that type of thing to help us out. Typical layouts. Here's a home system here, simpler. You see where the home is, the borders of the house and its amenities. And then the lines are covering loop back and forth in there. That's our drip system. And it's being served by what we call ATUs, advanced treatment units that are located in there on the site from home. Here's a next step up would be as one of our travel centers. This one's a large one that 25,000 square foot, trucks, everything you can imagine is going on in that place. You'll see in the purple areas, that's where our effluent and also our wastewater treatment plant is out there, and that's an extended aeration plant. Again, as we go through this, is when you're building up on it, we're also having to make sure we're out there locating all these. This is a very odd shaped looking one, but for a 250,000 gallons a day on the side of a hill. Contours are very important to us. We have to be very careful with them. This one like I said, it's used up about 60 acres for this water and for this particular subdivision and apartments that were going in. Here's another one. You see the layouts of our drip systems and stuff on these zone systems here. This is coming from a very large wastewater treatment area. We didn't have anything to do with the design of it, but from there we bring the water back to the sites basically for what's going on. Another one would be a large warehouse system, about 450,000. Getting them started, we start with our series. What we find, we have maps here showing where the areas are going. Sometimes the information is substantial. Sometimes it's lacking. This one here was one that was on more of a lacking side here. Traditional areas for wastewater treatment plants and dispersals are typically on the outside of one of these big projects. However, as time's gone along, now these things are moving into the areas, in the parks and those types of areas within our subdivisions. Here's two shown there with the homes in there, and there's an area in the middle there yet to be developed, whereas those areas are going to have the water on the sites themselves. Tools of the trade. All right, we're out here doing a little bit of site visit on our friend here, taking some readings into our soil surveys, where we're doing, looking at the depths of the soils, looking at what's going on, so we know how much water we can put on these areas. It's a very important part of our thing, and this goes back into our maps once we get going here. Comment on the equipment. GPS based equipment is lightweight and easy to handle by one person. Again, we're not surveyors, but we're the guys going out there and trying to find these things. A little bit more on that. We've got some bad sites. We're trying to get into briars and things like that to get these corner points and things like that. It's sometimes awkward in some of these brushed and natural areas. We also can use our finding elevation changes. The GPS has been a big help to us finding this is a particular site where we had about a 200-foot differential in our area, where the wastewater treatment plant is to where the tankage is, and then to where our disposal system is. We also design pumps and things like that. So those kinds of numbers are very important to us. Okay, moving back to the field here with our equipment from our plans. Our stakeout is a very big must. We have to make sure we're going back into the right places. So if you can see on this one, a lot of odd shapes out here along a lot of contours, finding those corners, making that all happen the right way takes some precision in getting back to the field with what we designed. Here's another look at we're putting on tanks, part of the wastewater treatment process, going into the ground. What the left side is the open tanks being completed, and then the right side is finished. These are aerated systems, but what's important about it is they've got to be precisely installed because of the gravity portion of these systems. As-built drawings. Back to the field again. Here's our technician here, going back to the field, trying to find those things that are going to be important to us, that we need to get back into our drawings, and that is going to be part of our plan that we turn over to our owners and to the local governments and that type of thing. Here's our plant again. If you have to imagine that all those corners and everything need to be shot and cataloged back into the plan, so that as time goes along, we'll be able to find all these things and keep an accurate track of what happened here at this site. Here's another area here with two different kinds of looks. We've got the left side where the pipe is uncovered and the valve boxes are shown there. Eventually that'll be covered up, and all you'll have possibly is just the little valve boxes. Right-hand side, you'll see numerous valve boxes sticking up out there, and all of those need to be kept part of the maintenance program and need to be cataloged properly so it gets back to the record. Back to the office for the final corrections. We send out our finals, correct plans to owners and the responsible government agencies. And folks, that's all I'm going to talk about today. We don't have that much time, but that's kind of just a bird's eye view of what an engineer in an engineering firm does with the on-site systems in these areas where we don't have actual true sewers. So our next speaker is going to be Chris Zuniga with Bad Elf. I'm going to turn it over to him.
Chris, you're on mute.
Hey, everybody. Thanks, Jim, for the introduction. Really happy to be here today. Jim, I appreciate that. This is my second time on an asset mapping webinar, so I'm really happy to be here, guys. Thank you all for coming and sticking until the end. But my name is Christopher Zuniga. I'm from Bad Elf's Geospatial Enablement team, and I help customers optimize field operations, and I provide training for them and their staff. But today, I'm excited to share insights on wastewater design and introduce a new offering from Bad Elf that I think is going to interest a lot of people here today. I'd also like to thank our partners. I think everybody did a great job of discussing this topic from a lot of different angles. I think you'll find that Bad Elf really kind of fits in as sort of a nexus between all of these different perspectives. So you've heard from APGLOS and Esri about the software and platforms that simplify data creation and sharing in the field. And you've also heard from James, one of our early adopters, who shared his experiences with the challenges and rewards of leading the industry in this space. So my goal today is actually to expand on those discussions by focusing on the need for a comprehensive data capture system inside of wastewater infrastructure design and maintenance. So we'll explore how GIS enhances wastewater management, the challenges of cross-sector data integration, and why flexible, standardized tools are key to improving data accuracy and encouraging collaboration. So here's a quick look at what is on the agenda. So we'll start first by providing insight into the current state of GIS inside the wastewater industry. Then we'll move to discussing the solution that Bad Elf has recently created to help kind of level the playing field.
Chris,
Trying to adopt.
you're not sharing your screen. Are you planning to share your screen?
Yep, I've got you right here.
Got it.
Right here. Can everybody see my screen? Awesome, perfect. Okay, so yeah, we'll start by talking about just the wastewater industry in general and how GIS fits in, kind of what the current state is. and then we'll move to actually discussing the solution that Bad Elf has created to actually fit this unique problem. But after that, I kind of want to really see where the rubber meets the road. So we're going to see where actually integrating that field data back into your database really comes into play. And lastly, I'll mention a bit about the geospatial enablement team at Bad Elf. So, but before we get started, we do have a quick poll. So if you could go ahead and fill that out. If this isn't your first asset mapping webinar, then you'll likely know that we always do a poll at the start. But this gives us some great data on who all is attending and at what rate you are all looking to adopt geospatial technology. So if you have time and you aren't driving or anything, we don't want you to do the poll if you're driving. Don't worry about it then, but we'd greatly appreciate it if you could fill out some of the questions. And at the end of the day, you know, everyone is at a different place when it comes to the geospatial journey. So there should just be a quick few questions. Just answer to your best of your ability, and we'll go ahead and we'll move on. So GIS, it connects data, teams, and projects. And in many parts of the country, the wastewater industry has not yet adopted the GIS revolution. James and his company inside of Texas are one of the early adopters of GIS in this way. But it's a huge deal that this hasn't happened, because not only does every dwelling, office, and shop need a working septic system, but this industry is also inherently tied to subsurface utilities, construction, engineering, zoning, real estate, all of it. And as we saw from Jim's presentation as an end user, he often finds himself in the mix of many different firms that all handle spatial data differently. They're each a part of the process that creates the final product, you know, that final product being a functional strip mall, neighborhood, office, or a single home. But this cooperation means that data sharing, communication, and spatial awareness on all sides is integral. This means that it's up to each of these organizations, each of these cogs in the machine, to not only produce and share quality data, but also be flexible in the way they ingest, incorporate, and act on data from partnering organizations. It's situations like this that we look for technology to answer our problems. And the ArcGIS platform and data collection apps like APGLOS Survey Wizard certainly solve some of the geospatial problems I just outlined. But to really deploy these technologies, one needs to actually set their field staff up with a multitude of things. It's not just, here's the software, you're ready to go, or here's the GPS, you're ready to go. You really do need quite a few things. And this is a conversation that I've had countless times, right? So an engineer or a GIS analyst will come to me and say simply, I need a GNSS receiver so I can collect points. What many people don't realize right away is that if you want a complete solution, you'll need a couple things. You'll need a rugged mobile device so that you can access your collection software in the field. You can have that interface, like Ray had mentioned. You also need mounting accessories like a survey pole and a phone mount for your GNSS. And if you're interested in high accuracy, then you need a corrections provider. And lastly, to kind of pull it all together, you need training for your people. So it really isn't as simple as, hey, I want to buy a GNSS receiver. Oftentimes, there's a lot of things that aren't accounted for along this journey. But we've seen this as a recurring theme in the industry. So we decided to do some research and come up with a solution to make all this just a bit easier. Kind of very similar to how Ray shared the invention of APGLOS, right? They saw a global trend in people needing to land survey, but not having the right tools. So we started a conversation across the spectrum. We met with local governments, on-site designers like Jim, and then also major engineering firms. And the message was clear. People are looking for a solution that's affordable, intuitive enough for anyone to use, and that fully integrates into their CAD and GIS systems. And that's why we developed the site survey package. So this bundle includes everything you need to start collecting high accuracy data right out of the box. And now, instead of picking between 32 different flavors of Baskin-Robbins ice cream to get your solution, we've tried to boil it down just to two choices, right? So do you want mapping grade or do you want engineering grade? The rest is all included, right? So it's a rugged Samsung tablet. It's not going to overheat in the field. It's going to work with all the Esri apps, going to work with APGLOS. Will also be bundled with a real-time corrections provider, mounting accessories, survey poles, survey bag, everything you see here. It's total. What we don't include is the survey vest, but maybe we should, because remember, guys, safety comes first. Always wear your vest when you're out collecting data. But yeah, so that's the site survey package. It comes with everything you need, and it comes with APGLOS Survey Wizard as a very utilitarian tool for being able to collect points easily and high accuracy inside of the correct coordinate system. But bundling these tools, it means that we're not only saving people time and effort, but we're also freeing them up from needing to become equipment experts. Instead, they can just focus on what they do best, and that's creating valuable data and insights for the communities that you serve. And I'd like to revisit what James spoke about. I think he did a great job of introducing this difference, but I'd like to just visit it briefly once more. And that's because standardizing waste management practices is challenging, and that's due to significant variations in regulation across the country. So standards around discharge, treatment, data accuracy, and permits can all shift wildly based on the jurisdiction that you're in, and this makes it difficult to implement a uniform approach that can help everybody. But again, adding to this complexity are the differences, right? So you have on-site systems, which are often decentralized and serve individual homes. And then you also have municipal systems like Jay showed, which are centralized and city managed and highly connected. But despite these challenges, one thing is clear, and it's if you don't know where your assets are, then they cease to be assets and they quickly become liabilities. Yet many professionals are still relying on sketches and field notes that don't have a consistent reference system. And it makes it really hard to integrate this data. And honestly, it increases the risk of errors. So we're hoping that by implementing a tool that's uniform, standardized, like the site survey package, more people are going to be able to create high quality data, reliable, and actually seamlessly integrates with their existing CAD and GIS systems. So let's focus a little bit on that last part, though, the integration with existing systems. So what exactly do I mean by that? And I think that Ray did a great job of introducing this topic. I really like this slide because it highlights the variety of end results that users can achieve with APGLOS Survey Wizard. You can see the complete water network design inside of AutoCAD. You also see the ArcGIS dashboard displaying hydrants, water lines, and then you also see a detailed technical PDF drawing that was exported directly from the app. It's highly configurable, that title block, right? I was able to put in logo, address, point of beginning, legend, scale, north arrow. It really is a complete package, whether you're trying to get to CAD, you're trying to get to GIS, or you just need a scaled drawing to work with. But yeah, so these examples, they show the flexibility of APGLOS and what it brings to field data collection. So it makes it much easier to adapt to the specific needs of a project or a team, or to integrate data that you've received, or to give it out to someone who needs it. And that's because APGLOS Survey Wizard, the field data is simple to reference and integrate, right? So the software supports imports from shapefiles, KML, DXF, and allows for exports in all those same formats, or as a PDF with the customizable title block. So that versatility means that whether you're a civil engineer using Civil 3D, or you're a GIS technician, or just a wastewater designer that needs a printed map, you can create and share precise and actionable data quickly. Plus, with native support for both global and projected coordinate systems, you can integrate existing data and export it in compatible formats without any hassle. And the rugged Samsung tablet is also part of the package, and it plays a big role, right? So this is going to ensure that field teams can rely on durable, professional grade equipment in tough environments. We often hear that people are bringing the personal devices, they're not rugged enough, they're cracking, they're overheating. This kind of solves that issue. But basically what we're trying to do is keep this setup and the staff using it focused on just collecting data rather than having to worry about the equipment. But ultimately, the goal of APGLOS Survey Wizard is pretty straightforward, and that's to make GIS and survey processes accessible and efficient. This setup really encourages collaboration, and well, it supports users of all experience levels. But we're hoping that it bridges the gap between engineering and GIS for a truly integrated and effective project management system. But solution aside, that just leaves us with the training, which is my main jam at Bad Elf. And that's because my specialty on Bad Elf's Geospatial Enablement team is helping organizations adopt new spatial technology. And because of that, I'm very familiar with the challenges that people face when trying to implement a new data capture system all on their own. As easy as I've made it sound, it's important to remember that engineering, GIS, and survey are all delicate sciences, and they require very careful attention every step of the way. And the best way for an organization to successfully adopt new technology is through education. And at Bad Elf, every member of our front-facing team holds a GIS degree, is non-commissioned, and is dedicated to supporting you until you achieve the results that you need. We're here to aid you in engineering magic. And thank you guys for having me today. If you'd like to continue the conversation, this is my contact info. But you probably heard enough out of me, so I'll go ahead and I will turn it over to the rest of the panel so that we can start the Q&A. Love to see what you guys have to say about all the presentations we had today. So I'll go ahead and stop sharing now and hand it back over.
Thanks, Chris. And get everybody over here from our panel discussion. So we've heard from the experts. I'm wondering, as we enter into our discussion period and our Q&A here, if I've heard some comments back and forth on various presentations, but I'll open the floor to each of you to reflect on some of the other comments you've heard. If you have anything that was top of mind that you wanted to share, we can use this opportunity to do that as people start to type in their questions.
I think it's just interesting to see how all this fits together. I mean, Jim, you're one of the first people that we kind of demoed this with, and honestly, your feedback has been amazing in kind of optimizing it. So I really appreciate your participation, Jim.
Okay.
Yes, and Jim, if I may add something to that, every information you that Christoph collects from you comes directly to our castle, and
Yeah.
from there we program it to make sure that it will function for you. So let's make the visit go around, right?
There you go.
So there was a lot of customizing that has happened based off of feedback like that. For example, the technical PDF export, right? That didn't exist before, but we realized
True.
that it might be needed for like an installer or a designer, and we worked with APGLOS to get that built.
So good stuff. So this, I was trying to keep track on my bingo card here, but I think this might be the first webinar I've been on in quite some time where the words LiDAR didn't get mentioned. And I think, many people that are in our audience perhaps are bombarded with all the options for data collection and maybe find difficulty sometimes in finding fit for need or fit for purpose data and going about things in a sensible way. So what I would ask each of the panelists to reflect on, I was jotting down some things. If I was a manager, LiDAR, do I even need that? How would that help me with my wastewater engineering and design? Imagery, do I need that? If so, do I need a special resolution? Do I need a special solution for that? I've heard a lot of people talk about things like disconnected edit. Is that something I need to be able to do this kind of thing? And then the other topic that I'd like to spend a minute on are data standards. Is my city, am I on my own to figure this out? Are there data standards that I can use to record all this information? Or do we all have to reinvent our own wheel? So those were just some of the things I was jotting down as I heard the great presentations that I'd ask each of you to reflect on.
So I'd like to start with your last question there, and where can you look to for standards, right? And I'd say look to the professional community and look to the regulatory agencies, right? So here in Texas, we have the Texas Onsite Wastewater Association, where I met Jim. We also have the TCEQ, the Texas Commission on Environmental Quality. They're actually about to update their standards, I think in March of 2025. So that's just a great place to start looking if you do need some standards. But in terms of the role that GNSS plays, I'd say, depending on what you're installing in the ground, you need to know the elevation, right? So elevation oftentimes is something that's being highly focused on now in the current climate, right? Everyone's interested in the digital twin, digital delivery, 3D data. I'd say, trying to have RTK corrections, trying to create engineering grade data that's very tight vertically could be very important in the way that GNSS plays a role into this and standards.
Yeah, kind of on top of what Chris is saying. Many years ago, it was people for field maps and stuff. It was people wanting to get that Z value of the wastewater, and that's kind of come full circle through working with engineering companies to do that or partners or whatever. But yeah, that's been a thing, and now it's here and stuff. So yeah, I see there's a couple questions as well whenever we
Yeah.
get to that.
So, any Ray or Jim, did you guys have any comments about that?
Yeah, just to step in on that. Oftentimes, or currently, we've got one or two projects now that are fairly large, where a lot of reshaping of the sites being done, especially in Central Texas, where we have so many hills and limestone, that type of thing, and they're reshaping. So a lot of those areas that we're going to use for wastewater disposal, the slopes are changing, things like that. So going back to your LiDAR question, if it would be a locally done flyover, whatever you want to call it, to get that information to update our information, because we're just guessing on what the engineer thinks it's going to look like.
Very nice. Yeah, before the packages are let.
Yes, sir. Mhm.
Ray, anything from your side?
Not too much that Chris already told, and I guess also with LiDAR and all that, and getting still, I think Jade mentioned that on the Z value, which is becoming more and more important, especially there. So definitely, I agree upon that. Maybe the combination of so you need at least ground control points, even if you do the LiDAR and all the pound point clouds. You definitely need some ground control points, and the only way you can do that for now, it still has to be some land surveying, and at least if you have to make a drawing on that. And I definitely think James can add that too, right? If you get some slope and you use maybe drones or whatsoever, or LiDAR functions, you have to get somewhere points, because there are too many points in the LiDAR that's a little bit what I think it will go up to.
Yeah, that's a great point. I never hear anybody saying, I wish I had less data. But I also am mindful that when people tell me they want LiDAR data, oftentimes what they really mean are better contours or better elevations or something. They want some derivative of the LiDAR. They may not need the LiDAR in and of itself. I see a couple of questions coming in online here, so let's get to those. Question for Chris, I think. It says, what tools are combined with ArcGIS to do simulation for a city wastewater network design?
So I had seen this question come up, and I've been chewing on it a little bit. I'm not 100% sure I'm certain exactly what you're asking, but I'll do my best to answer. I'd say there's a lot of tools that are involved, right? So whether you're talking about just hardware and equipment, like the site survey package, or you're talking about an actual interface, right? So maybe you have all of your wastewater network design information hosted on ArcGIS Online. Field maps would be a great option to be able to see that in the field, be able to interface with it in the field. You could also export it as a shapefile and upload it into APGLOS. They do have a file limit size though, so it probably couldn't be the whole city. But you just need to determine based off the requirements and the project, what are those best tools, and that's something that we're best suited at advising customers on. So if you'd like to talk a little bit later, I'd really love to learn a little bit more about your specific use case and hopefully give you a better answer.
Perfect. Thank you. Our next question is wanting to hear on CMMS recommendations with Esri integration. Anybody want to tackle that one?
Yeah, I'll tackle that from Esri's side. So yeah, your CMMS or your customer billing, there are certain billing softwares that are out there that do a lot. One of them that I see in a lot of my accounts and other accounts around is called what I call it CUSI, C-U-S-I. It's Continental, forget the whole thing, but I refer to it as CUSI. So if you just type in CUSI, then you'll be able to find them. And there's many other ones that if you want to send me a direct email, I can make some other recommendations for you.
Okay, great.
Let me put my email in the chat. I don't think I had it in the.
Sure.
And just to speak to billing, right? And this brings the whole conversation back to spatial, right? To geo. And that is, if you don't know, what water meter is whose, or how much water is flowing from it, or where it is, you can't really bill that person appropriately, right? So Oftentimes, poor water management from a city can often lead to uncollected fees. So if you are a GIS person or you are working and you are trying to kind of upsell, hey, maybe we need to actually get all this stuff mapped, that's a great ROI kind of arguing point that you can bring up.
Yeah, thanks for that input. We had a question that came in earlier, I think that got answered online regarding updating. This was to Jay on the Esri software, updating workforce transitions to tasks and the timing of that. I think Jay had replied, "No, I don't want to put words in your mouth, Jay. If you want to speak to
No
that
problem.
real quick."
Yeah. So tasks is, workforce is going to be moved into field maps, and that's now going to be called tasks. As I said, task, I believe, is going to be released in first quarter of 2025, according to the product manager. So that's what I have for that, and I assume the inspections would follow along with that. I don't, other than knowing that task is going to be there, and that's about all. So look to look for information on that. I also do our water newsletter, all about water, wastewater and stuff. So if you want to do that, you can send me an email. I'll be happy to add your name to my water newsletter that I send out monthly. So
stay tuned on that one, it sounds like.
yeah.
This is a question maybe for Jim, but I'll throw it out to everybody. I know sometimes managers and departments can get sort of confused. The difference between a geographic model and a hydraulic model. I'm going back to the title of our session here, is for engineering and design. And whenever you start looking at inverts, you start looking at flow lines, you start looking at all of this data for whether a local system or a connected system. What are some of the considerations that people might want to take into account around that?
So I'd say the two biggest things are the reference system, whether you're getting data and you're trying to get it to line up, or you're creating data and trying to put it into a greater database. That, and then also height, right? So there is the difference between ellipsoidal height and orthometric height, right? So orthometric height is going to take into account gravity, right? So on an ellipsoidal height, you might have one point with a higher elevation than the other, but water can flow the opposite way that you would expect. And that's, again, because you're not taking into account gravity, right? So it's industry standard to provide orthometric heights, apply that geoid offset, apply gravity, and have an orthometric height as your deliverable. That and managing your coordinate systems, I'd say, are the two most important considerations.
Anybody want to add to that?
More from a user's point of view, and maybe that's where they're coming from in our designs and putting things together. You've still got to know these distances, and you've got to know the changes in elevation as you go along that path. Sometimes we're pumping water several miles in some cases, and so we've got all that information. All that mapping and logging has to be correct along that pathway. So these geospatial tools that we can use to go out there and verify. My firm, we do a lot of pump designing and that type of thing. So that's an extremely important thing to know. And just hardcore data still works pretty good.
Yeah, I always
brings up a great point.
Yeah, I used to work in civil engineering in a different life, and I remember designing and building a force main that ran downhill, and gravity wasn't getting the job done. Yeah. Okay, fantastic. We're closing in on the final minutes here. So if there are any additional topics that maybe have come to mind during our discussion, or if you have any final thoughts, we'll go around the panel here and give an opportunity for each of you to share. Somebody want to start it? Jay, how about if you start us out? We'll just keep our same order previously.
Yeah. All I'd like to say is just look at the solution pages. Aaron, I believe you said we don't want to reinvent the wheel earlier. And that's a way of not doing it and be agile and customize second. So that'll make your life a lot easier. We consider those quick wins. So that's what I would be a good takeaway from today with my sewer manhole inspection solution.
Very good. Thank
Ray?
you. You're up next, Ray.
Yeah, well, first of all, I want to thank everybody for inviting us, and I hope my presentation can give some insight on other packages that can be like the center of data collecting and that's what that's what I want to say. And again, thank you. And I think hopefully people can download it and test for themselves, because any feedback from that, you know, we do have professionals like James, for example, that are already using it, but it can also be handy that anybody who can respond to that, you know, maybe you can alter that, maybe you can do a little bit of this so it can be a little bit more easier to use, and help everybody to start land surveying again and make it a good solution what we provided, hopefully. So
Very good. Jim?
Yeah, my goal in the whole thing was in how I got involved with with the GPS, and especially through with Bad Elf, was to trying to find a solution so that to get that information we needed in our designs on a timely manner without having to go out and try to find a surveyor. Trying to get on today, that's almost impossible to get anyone for any quick turnaround. So, you know, a lot of times we just need that. We got that pipe run, we might have that. So the GPS equipment and especially with what we've been learning with the help of the folks at Bad Elf, Chris and Nick over there have been really big helping us through that. That now we can walk out there with confidence and say, okay, this is what we've got, and then depending on the level of accuracy, we can dial it up if we have to. And we know how to do that too. So that's been a big help. So anybody that's in the design and you know, in the layout part of it as well. You might be an installer, contractor. This is equipment that's going to be helpful. So,
Very good. Chris?
So I saw there is a follow-up on the question that I answered previously
Oh,
about
okay.
what tools to use to simulate the wastewater network design on a map. And they specify they're talking about software tools. In Jay, he mentioned ArcGIS Solutions. ArcGIS Solutions is a great way to start. I'm not sure if you have just a regular online license or an enterprise agreement, but you can actually take all your existing data and you can put it on ArcGIS Online, and you can see it in the field with field maps or soon-to-be tasks. But yeah, so that's probably the way that I would recommend going about that, especially if you have massive amounts of infrastructure. So hopefully clarified your question there a little bit. I just want to say we're happy to be here. We're happy to serve as kind of a nexus between software providers and end users. And I really want to emphasize that we don't take training lightly. We don't take geospatial enablement lightly. We really are there for your success. I get a little too invested sometimes, but I really just love to see the things that people do with data once they can collect it confidently. So just thanks for having us, and we're always happy to sponsor.
Very good. So again, I want to thank all of our presenters and all their presentations today. Super valuable, super insightful, and I'm sure there'll be continuing conversations. Thank you to Connect Me for hosting the webinar today. The recording will be available for download after the event is concluded, and I think emails go out whenever that availability is online. If you need a certificate of attendance, please contact at attendance@assetmapping.events. And again, thank you all for attending, and we look forward to the next webinar on asset mapping. Thank you.
Thank you all. Have a good one.
Take care.
Take care.
thank you. Bye-bye.